Okay, so this video is just going to be about bearings. So bearings are a way of measuring direction, and they're particularly helpful for people who use navigation in their everyday lives or jobs, such as pilots or captains of ships, things like that. Okay, so you're hopefully all familiar with the 4 compass points. So I've marked them here: north, east, south, and west. Okay, and bearings are measured from north. So a true bearing is measured from north, and north is 0 degrees. Okay, and we measure clockwise from north. So you can see, going clockwise is this way, that if I were to go east, directly east, I'd be on a bearing of 90 degrees. Okay, south is on a bearing of 180 degrees, and west is on a bearing of 270 degrees. Okay, and everything else in between. So the first thing we're going to look at is how you would measure bearings using a compass. Okay, so this question says, find the true bearing indicated by each red arrow. So in this case here, you'll see that this arrow is pointing off this way, and it's between north and east. So you know your bearing is going to be somewhere in between 0 and 90 degrees. Okay, so if we move the compass over and make sure we've got it lined up. So we've got 0 degrees this way, and we're going to measure clockwise, and we can see that that is on a bearing of 58 degrees. Okay, so when we write bearings, we always use 3 digits. So in this case, we have a bearing of 058. Okay, degrees. Let's try the next one. Okay, so if we place this compass down here, again, we can see that the red arrow is pointing between south and west. So we know that our bearing is going to be in between 180 and 270 degrees. Okay, so measuring that from north, so I'll put it back to the beginning. So we're at 0 degrees, and we go clockwise all the way around past 180 degrees, okay, to here. We can see that that's on a bearing of 210 degrees. So that's already 3 digits, nice and easy. Our bearing there is 210 degrees. So you can see by using this that you wouldn't need to indicate whether or not you're going north, east, south, or west, because the bearing is between 0 and 360 degrees. That's all you need to work out what direction to go in. Okay, so the next thing that we're going to do is we're going to measure the bearing between 2 places. So let's say you had these 2 places, A and B, and you wanted to know on what bearing one place was from another. So the first question says, what is the bearing from A to B? So the wording of these questions is really important. You'll notice it says from A to B. So that means we're going to measure from A. So we need to start by putting an arrow pointing towards north from point A. Okay, and then the next thing that we're going to do is we're going to join A and B together with a straight line. And then we're going to measure the angle from sort of north, all the way to there. So that's going to be our bearing. Okay, so we'll just use our compass to measure that angle. So we need to get that centered there. And we're going to measure clockwise. And I haven't got my compass quite centered. There we go. Okay, so that looks like it's about 72 degrees. So the bearing from A to B is going to be on a bearing of 72, and we write that with 3 digits, so it's 072. Okay, now the next bit says that you want to find the bearing from B to A. So this time what we're going to do is we're going to draw an arrow pointing north from B, okay? And what we want to measure is we want to measure this whole angle here that goes all the way around, okay, from north clockwise to that line joining A and B. So we'll just use our compass again, and we'll get it nice and lined up, and then measure. So we set it back to 0. You can see that if I go all the way around, all the way, I'm going to get to 252 degrees. So that's my bearing from B to A. Okay, so that second one there. Okay, so the important thing to remember from that is the wording. If you see that it's from A, okay, that's where you draw your arrow measuring north, and you measure from north, okay, clockwise. If it's from B, then you start with an arrow measuring north and clockwise from that point B. Last thing we're going to do is we're going to look at a word problem. So this question says, Matt hikes for 8 kilometers from his base camp on a bearing of 290 degrees. How far north is Matt from his base camp? So first thing we should always do with a word problem when we've got something like this is we're going to draw a picture so that we know what's going on. So Matt goes from his base camp on a bearing of 290 degrees. So there's his base camp. And he's going 290 degrees, so I'm going to draw an arrow pointing north from his base camp. Okay, and I'm not gonna measure 290 degrees this time because you don't really need to do that. As long as your maths is correct and you've got it in the general position, you're fine there. So we should know though that 290 degrees is just over 3/4 of a turn. So 270 degrees would get us going directly west. So it's just going to be a little bit further, maybe up about here. So if we draw a line to show the direction that he's walking in, so he's walking sort of that direction there. Okay, so that's on a bearing of 290 degrees. And it says he walks for 8 kilometers. So the length of that line there represents 8 kilometers. And the question is asking how far north he is, so directly north from the base camp. So that would be the measurement from where he ends up to there, so a perpendicular distance. And you can probably start to see that we're going to have a problem involving a right angle triangle. So when we have problems using right angle triangles, you're going to have to use your knowledge of Pythagoras and of trigonometry and a little bit about angles and things as well. So the question wants to know how far north he walked. So again, that's this side here. That's that length. How far he walked is that length here. How far north, sorry, he is. Okay, and the thing that we know in this right angle triangle, well, we know that's a right angle, and we can actually work out this angle here, because we know this whole thing here is 290 degrees, and if you go from there up to this line, that's going to be 270 degrees, then this remaining bit is going to be 20 degrees. Okay, and we start to see hopefully something familiar here. We've got a right angle triangle, we know an angle, and we know a side, so we can work out the other side using trigonometry. So I'll write SOHCAHTOA here, and we'll start to label our sides. So the side that we want to know is the opposite to the angle that we're given. And this 8 kilometers here is the hypotenuse. So because we've got the opposite and the hypotenuse, we're going to use our sine ratio. So we know that sine of theta is equal to the opposite over the hypotenuse. And let's fill in the values that we know. The sine of 20 degrees is the angle that we know, is equal to the opposite, which is what we're trying to find out, over the hypotenuse, which is 8. So to solve for the opposite side there, we're going to do 8 times the sine of 20 degrees. And hopefully you're pretty comfortable solving these kind of trig problems from the other lessons. So you just go ahead and put that into your calculator, and you should get an answer of 2.7 kilometers rounded to 1 decimal place. Okay, so when you're doing a word problem, really important to be able to draw a picture sort of accurately using bearings, and then you'll probably have to use Pythagoras perhaps and trigonometry in order to solve it.